Alright, so now let us discuss evaluating limits. Let us do the finite limits and studied limits, special limits, everything about limits. So remember, a limit is a boundary. Yeah, so this guy should learn to know his limits, or else they'll chop off your head. Yeah, so now this video is a continuation from where the previous one ended from. Yeah, so we're now going to look at finite sets at infinity. So this one will just be quite very brief. It is whereby we just simply look at the behavior of an infinity limit. So when x is approaching infinity. Yeah, so I came up with this. So like this, we can say they are the rules. Yeah, so these are the basics which you should know about infinity. So like when you divide a number, so let's call any number like x. When you divide any number by infinity, you get a 0. So 1 over infinity is 0, 2 over infinity is 0, just like that. And then for the rest of the operations, if you add a certain number plus infinity, it will continue being infinity. And then if you subtract a certain number by infinity, it will continue being infinity. And then if you multiply a number by infinity, it will be infinity. Yeah, just like that. So we're going to evaluate now limits at infinity. Yeah, so taking into consideration of what we've just listed out. So this is an example we're going to have dealing with the infinity. So let's compute the limit as x approaches infinity, 5 plus 1 over x. So remember, we just substitute. So when you substitute, we're not going to bring down the limit as x approaches infinity. This is 1 over infinity. So 5 plus, what is a number divided by infinity? Like we have said, it's 0. And then 5 plus 0, that's 5. So you can see this as an MCQ. Yeah, you can see it as a multiple choice question. Yeah. And then the other one, the limit as x approaches negative infinity, we have pi root 3 and then negative infinity squared. Oh, and I also forgot, so if you add infinity and infinity, it will be infinity. If you multiply infinity by infinity, it is infinity. Yeah, it is just the same like that. And then if you divide infinity by infinity, it is an intermediate form. This is not equal to 1. It will just be like that. We can even say it is infinity. Yeah. So this is when we square. So we have 3 pi root 3. So infinity by infinity, it is just infinity. And then anything divided by infinity, it is 0. Yeah, so this is how we go about it. So just take note of these basics I've taught you. They'll be able to help you to answer almost 80% of questions that will deal with this. So just a quick recap. Infinity plus any number, it is infinity. And then infinity minus any number, then the number, it will just go on decreasing and decreasing, negative infinity. And then infinity times any number, this will be, so infinity times any number, it is infinity. And then if you divide any number by infinity, it is 0. Yeah, and then your question would be, what about if we have infinity over any number? This will be 0. Yeah, and then also take note of these, then we are good to go. Yeah, so now let's go to discussing the other parts. Yeah, so let us talk about sided limits. One-sided limits, what should we know about them? But before we can go to sided limits, it would be better if I teach the special limits. Yeah, so let us talk about the special limits and then we'll go to the other one. Yeah, so almost done. Special limits. What's special about certain limits? So I have a lot of special limits, but some of them are not really special. Yeah. So these are the special limits that exist. There are even more than this. So what is there is that when you open a textbook, you find a lot more. There'll be a number of other limits, and then in the lecture slide they only list this, and then here we only list these two, and then in the exam or in the test you only see this. In the exam they'll bring that. Yeah, and then for these I do not pay much attention to them, but you can just study them for safety in case it comes as a multiple choice. When this happens, it will be equal to what? You have to know it is equal to 1. The limit as x approaches 0, the exponent x minus 1 over x. Yeah, but for this we'll come to it when we go further in calculus. Yeah, we will apply this somewhere and a little bit of this. So let us now talk about the special limits. So the limits which are really special are these ones, this and that. So the limit as x approaches 0 of sin x over x is equal to 1. What does this mean? So what we're saying, the first one is that the limit as x approaches, is it 0, sin x over x is equal to 1. And for this one you might argue like, okay, but when we substitute x here it will be 0, this will be infinite, this will be undefined. So I think this is the part where now this guy oversteps the boundary. He oversteps the boundary and faces his fears. He'll just be like, no, today I'll try my luck. And then he proposes, they reject him, he goes away. Yeah, so now talking about limits, so this one we don't really substitute. There is a way of proving, but I don't want to prove that. We'll just waste so much time. Yeah, so we just know that the limit when x is approaching 0, sin x over x is equal to 1. So this is true even when you have something like sin, even when you have x over sin x, the limit as x approaches 0, x over sin x, yeah, this you can just conclude that it's equal to 1 as well. Yeah, so this is true even when you have like here you have ax, here you have ax over ax. So as long as what is here is exactly the same as what is there, then the limit is equal to 1. Yeah, so like here you can see we have ax, even here we have ax, then this will also equal 1. Yeah, so we're going to look at a few questions. The aim will just to make sure that here and there is the same. As soon as it is same, then we're going to finish it up. Yeah, so that is the first part. And then what is the other part which we should know? So many questions will come from this first one, and then a number of other questions as well. They'll come from the other from this other limit. X approaches is it 0? So I have 1 minus cos x over x. 1 minus cos x over x. So this will be 0. So wherever you see the whole lot of this, just write it that it's equal to 0. It's a nobody. Yeah, so now let's get evaluating how will questions come. So we can have an example. What example can I give? So let's say you are told to find the limit as x approaches 0, and then we have sine 3x over x. Yeah, so what can you do when you have such? So here you have to remember that okay, when I have the limit as x approaches 0, okay, let me write that better. So when I have the limit as x approaches 0, sine x over x, the whole lot of this is 1. Yeah, so this is our key. So remember I said as long as the thing here is the same as that, then everything equals 1. So like here we have 3x, but here we have just x. So in such a case, this is not yet equal to 1. We have to make sure that even here we have a 3, that's when it will be equal to 1. So I've even given you a hint. So what we need to do is we multiply by 3, but we can't just multiply it down by 3. Even on top, we should multiply by 3. Yeah, so what is 3 times this? So we already have a 3 here. We do not want to have a 9. Then the things will be different. So 3 times the whole lot of this, we can take it to be in front. So on the rules of limits, we have the constant rule. Yeah, so when you are multiplying a limit, it simply means the number is like outside here. Yeah, so the 3 goes out there. And then this 3, we can also write it here as well. But we do not want to write it there. So sine 3x over, we have x. So the 3, it can come here, so that we have 3 over 3. So we haven't changed anything because 3 over 3 it is 1. And yeah, so but since we're not going to take it that side, we're just going to bring it here. Yeah, and then in this case we have a 3x. Yeah, so since we have 3x and 3x, it means that we have 3 times the whole lot of this. Since we have the same thing on top and below, then the whole lot of this is 1. So 3 times 1 is 3. That's how you evaluate such limits. Yeah, so can we do another one? What example can we think of? Yeah, so now let's think of a case where this is a lecturer's favorite, where we're going to combine. So like x is approaching 0, and then we have sine 5x over what can I put, over cos anything, cos 2x, like that. So in this case, then we would first have to separate. Yeah, so we'll separate, meaning we're going to have the limit as x approaches 0. So we have sine 5x times 1 over cos 2x. So usually for cos we do not have to worry much, because even if x is approaching 0, cos 0, it is just 1. Yeah, so here I've separated the two. Yeah, so like we can multiply back 1 times this, it is that same thing, and then cos 2x times here, it will be cos 2x. So this simply means that here we have an over 1. Yeah, so I've said for cos there are no problems. We're just going to substitute where there's x, we'll put a 0. Yeah, but for sine, if we put a 0, then sine 0, we're going to get something we do not want. So what we're going to do is, since we have a 5x here, what do you think we should have here? Think. Yeah, so what should we have? Since we have a 5x, so obviously we should have a 5x as well. So we'll multiply throughout by a 5x. Yeah, so I'm multiplying by 5x because we can cancel it out. So I haven't changed the meaning. Yeah, so 5x times this, we already have a 5x here, meaning it will go in front. So we're going to have 5x there, it's in front, and then we have limit as x approaches 0. So the limit as x approaches 0, we have sine 5x over 1. So this 5x which is down, if we want, we can bring it here. Yeah, we can bring it here, but we'll just put it here so that they can match, times. So this limit, it is for everything here. So we get our times 1 over cos 2x. Yeah, so at this point we're going to say, oh, okay, so I will simplify, or first we'll distribute this limit. Remember, it is for both of these. Yeah, so we're going to write the limit twice so that when we simplify we do not have problems. So we have a 5x outside, and then the limit as x approaches 0, sine 5x over 5x times, again, the limit as x approaches 0, 1 over cos 2x. Yeah, so the whole lot of this, the limit as x approaches 0, were 5x and 5x, meaning, so this is the 5x is outside, times the whole lot of this is 1. Yeah, times, so the limit as x approaches 0. So remember, when we substitute what is x, when we put 0, then we stop writing down the limit. Yeah, so let us substitute. This will be 1 over cos 20. Yeah, so I hope you haven't gotten so confused. So this is 5x times 1 times 1 over 1. Yeah, cos, so this is 2 times 0, 0, cos 0, it is 1. Yeah, then the final answer will just remain 5x. Yeah, so this is 1 times 1 times 5. Yeah, that's how you work it out. Yeah, so let's do just or haven't yet done anything relating to this. The limit as x approaches 0, 1 minus cos x over x. Yeah, so when you see that you're having something that is mainly relating with cos, then if we are going to have the same denominator, yeah, so usually here we should just have cos x. We say that that part is 0. Yeah, so let's have an example. Okay, so this is what we have. Yeah, so I just want to do something relating to this one here. Okay, so here we're going to do this question. Yeah, so this special limit is not very commonly used. Yeah, but I'll look for more questions on this and then we'll handle them. So how can you work out this one? We've been given that limit, so we can rewrite this. We can say we have the limit as x approaches 0, -1 plus cos x over x squared. Yeah, so that at least it now looks like that one. So what we're going to do now is we'll factorize. So let's factorize. We'll say the limit as x approaches 0. So here when we factor out a -1, we're going to remain with, so I factored out a -1, we just remain with 1. Yeah, because -1 times this, it will take us back to the original one. So we factored out -1, and then this positive, we factored out -1, it remains negative, and then we have cos x. So this is over x squared. Yeah, so here we've just brought out the negative outside. Yeah, in simple terms, we've brought out the negative outside, we've written -1. So meaning here the negative has gone away and this one has become, the positive has become negative. Yeah, so that even if we multiply them back, negative and negative, it will be positive. Yeah, so we factored out the negative, and then we can now factorize further. So this -1, if we have a constant in the function, we can take it outside. Yeah, so this will be -1. We've taken it out over, so we have 2 x's here. We're going to take out 1 as well. Yeah, so and then we'll remain with the limit as x approaches 0, 1 cos x over x here, we have just remained with 1. We factored out the other one. So at this point it looks like the general one, which is right there, which is here, 1 minus cos x over cos x. So the whole lot of this, according to what we know, the whole lot of this is 0. So times 0, and anything times 0, it is 0. Yeah, so this is how you can work it out. So usually when you have something dealing with cos x minus 1, you are just going to end up with a 0 somewhere. Yeah, so we'll work out on more examples. Yeah, but not in this video. So these others you can multiply by the conjugate of the numerator. Here you just put a plus, you multiply throughout. Here you simplify the numerator. The numerator as a fraction, it has 1 over 2x, or 1 over 2 plus x. It has 1 over 2 plus x minus 1 over 2, and then it's over x. So you simplify this, you make it as a single fraction, and then you divide by x. So you can try it out, and whenever you get stuck, you are always free to to inbox me. Yeah, and then this one, it simply means that down here we should also have a 3. So meaning we multiply throughout by 3. So meaning these 3 will go outside. Yeah, and then we'll have limit x approaches 0. And then we'll have sine 3t over 3t. This one has come here. And then this one, we've taken it outside. So the whole lot of this is 1. So 3 times 1, 3. Yeah. And then and all these, so you just have to have a starting point. Here you just factor out 1x. 1x will go outside, and then you're going to have this sine x over x. Yeah, so the whole lot of this is 1. So the final answer here is 1. Yeah. And then here you try to rationalize the numerator, you multiply by the conjugate, you see why you can cancel if possible. Yeah, you're just moving like that. And then this satanic one, try simplifying it. Yeah, so when you have a cube root, it simply means to the power 3. Yeah, so you have to the power 3. You can multiply both sides by x power 3, even there x power 3, so that this and that will cancel. Yeah, so first you try and then you come like, okay, here things are not so well. For this one, quite funny, 32 can be raised to the power 5. So minus 2 power 5. Yeah, so you can open x minus 2, x minus 2, x plus 2, 5 times. Yeah, and then you cancel out with this. Yeah, so the key thing is just to remember that 32 is power 5. Yeah, so I don't want to go into too much detail. Yeah, you've learned the basics, so you should try practicing on as much as other things as you can. So now let's make progress. Let's do one-sided limits now. So what do we have to know about one-sided limits? So one-sided limits, so I'm sure some people feel attacked, like won't we be attacked as well in one-sided relationships? So the one-sided limits, they are simply so we have a function. So you know functions, like we have a parabola, we have a root of a function, it looks like that. We have yeah, so you know how to plot different kinds of functions. So one-sided limits will normally we analyze them using the Cartesian plane. Yeah, so here where do I start from? With the one-sided limits. Okay, so let's say want to plot the graph of y is equal to y is equal to what? 1 over x, for example. Okay, now this one, it won't make sense for a start. What can I think of? My idea is gone. Yeah, so the one-sided limits, it is whereby we'll take any form. So like this is the graph of y is equal to root x. Yeah, so now when we're talking about one-sided limits, it's simply a part where we look at a limit from a specific point of view. Yeah, so this popular social media abbreviation. Yeah, so we look at a limit from a particular point of view. So like when x is approaching 0, where is it coming from? Are we looking at it from the negative side or from the positive side? Yeah, that's one-sided limits are. So now like in this case, we can have a limit whereby I just couldn't think too much. I don't want to stress myself. So like let's say you have a function, we're going to say, so this is the graph of root x. So now what if we have the graph of root x plus 2? Yeah, so the graph of root x plus 2, or we can write minus 2. The graph of root x minus 2 from functions part 1, what we looked at in semester 1. Oh, that was graphs of functions. So it would be like somewhere here. Yeah, so I'm just doing some rough work. Yeah, it will. So this is 0, 1, 2. It starts from here. It goes there. Yeah. So there are values whereby this function, it can be complex. Like for example, values which will make it to be negative. Let's say if x is 1, oh, I've written negative. If x is 1, then it means we're going to have 1 minus 2, which would be equal to negative 1. So this is an imaginary number. So like if we were to plot, we would say that this is the graph of root x minus 2, but it's going to have, so like this is the point where x is 1 in the y-axis. So like would draw a dot. Yeah, so a dot simply means not part of the solution. Yeah, so this is not my best example. Yeah, so that is just a mere introduction. Yeah, so inside one-sided limit, it's whereby like we can have a function, it is continuous, but there's a removable discontinuity. Yeah, like if there's a dot, then that's not part of the solution. Yeah, so but if we have a function, it is just continuous, it means this is all the values are in the domain. Yeah, but when there's a dot, it means the values are not part of the domain. Yeah, so now how do you evaluate one-sided limits? So for the one-sided limits, like I said, we normally just look at, we'll be dealing with the x or y plane. Yeah, so let's go straight to an example. Okay, so before we even do an example, firstly we have to understand what qualifies a limit to be a limit. So there are three conditions that must be satisfied. So if we have a function like f of x, and then want to determine, we're looking at the limit when x approaches a certain number, like maybe a. So the conditions are that when we approach this limit from the negative side of a, when we approach it from the negative side of a, it should give us a certain number, like it should give us b. And then when we approach it, when we approach the same limit from the positive side, when we approach the same function from the positive side, it should give us b again. Yeah, and then also finally when we just substitute, so like when we just substitute where we say f of a, so meaning in the function where there's a, when we substitute again we should still get b. So the limit has too much restrictions. Yeah, so let me put you into perspective with this example. Like for example, if we have f of x is equal to 1 over 2x. So if we want to determine whether the limit, when the limit as x approaches 1, if we want to determine whether this limit exists, it has to satisfy this condition. The first one is that when we approach 1 from the negative side, it should give us a particular number. Yeah, so like let's just quickly do it. So 1, you know how yeah, okay, so this is 0, 1, 2, the numbers are just going like that. So when we approach 1 from the negative side, meaning like we can get 0.9. So here where there's x, what happens when we put 0.9? So it means we're going to say 1 divided by 2 times 0.9, and the answer is 0.55. So or 0.56. We've approached the limit from the left, but what if we approach it from the right? Like so from the right, it means we're getting a number greater than 1. We can get 1.5, 1.1. So what happens when we get 1.1? Then we're going to have 2 times 1.1, and then you divide it. You divide 1 into it. So here when you put 1.1, the answer you are getting is 0.45. So you can see that when you approach from the left and when you approach from the right, you're not getting the same thing. The other one is 0.45, the other one is 0.55. So the limit will not exist for such. Yeah, and then even for the third condition, it simply means we directly substitute. Yeah, so like here, if we put 1, it means 1 over 2 times 1 is 2. So 1 over 2. So when we put 1 here, the final answer is 1 over 2. So the answers are different. When you get from the negative side, when you get from the right hand side, the positive side, you are not getting the same things. Yeah, so we do not usually prove like this because it would require you to use a calculator. And mathematics at A level doesn't require calculators. Yeah, so this is just for explanation. Yeah, so but in case the lecturer just wants to punish you, you did something bad, they'll ask you to prove without giving you a graph. Yeah, so but when we're given a graph, that's when it becomes way too easy. Yeah, and the graph is confusing only when you haven't learned it. Yeah, so but let's make it all simple. So here the question is find the limits of the function graphed. So the whole lot of this is one function. Now it has segments. Yeah, it has discontinuities. Like it has started from here. Instead of just going straight, it goes down, and then it continues. It goes up, it goes down. So this is just one function. Yeah, so we're going to find the limits at each point. So we have the first point 0, the second point 1, 2, 3, 4. We're going to find the limits, 4 limits. Yeah, so this is a typical exam question. Yeah, and then we're also going to look at an exam question shortly. Yeah, so where do I start from? So let us look at the point where x is 0. Does the limit here exist? So for the limit to exist, it means that if we follow the limit as x approaches 0 from the left hand side, it should be the same when we approach the limit as x approaches 0 from the right hand side. So here we just follow the graph, like okay, 0 is here. From the left, we do not have any graph. So on the left, limit does not exist. The limit does not exist. Here on the left, we don't have any graph. Yeah, and then what about on the right? So on the right, we now want to come to 0, meaning we're coming in this direction. Yeah, so we're going to start from the like anywhere, like we're starting from here, we're going until we reach the point where the WAV is 0. which is there. So when we're approaching 0 from the right, the value which we have, it is 1. Yeah, so this is the value which we have. So I think for now it hasn't made so much sense, but just hold on. Yeah, so from the right it's very easy to follow through. We'll follow the graph is or following it like this, but it just fell down and then it is taking us to 1. So from the right it is 1, from the left it does not exist, meaning the limit in itself just it does not exist in this case. Yeah, so the limit when x approaches 0 does not exist, because from the right and from the left are not the same. Unless if they are the same, if here it's 1, even there it's 1, then it does not exist. Yeah. So let's go to the next point, which will clarify things better. So at the point 1, what happens? So let us approach the limit when x goes to 1 from the negative, and the limit when x goes to 1 from the positive. So here from the negative, the negative we go like this. Yeah, so we're coming down to 1. So when we reach the point 1, what is the value which we have? We have a 0, the y value. We have a 0. So when we're approaching 1, from the negative, we have a 0. And then now what if we're approaching 1 from the positive? Yeah, so we're going to come from here up to where we find 1. 1, it is right there. So this is the value of 1. Yeah, the x value of 1. So we've reached this point. So what y value is it going with? It is going with positive 1 there. Yeah. Okay. Yeah, so we found from the left, when we came from the left, it is 0. And then when we're coming from the right now, it is at 1. Yeah. So since from the left it's 0, from the right it's 1, then the final limit, it does not exist. Yeah, so you conclude therefore the limit when x is approaching 1 does not exist. Yeah, so let's practice on another one. So we've seen, so both of these points, they're on 1. It depends on where you are coming from. When you're coming from the left, the graph was coming down, and then when you are coming from the right, it was going like this. Yeah, so let's go to 2. This point, we're going to approach it from the left and from the right. So what are we going to have? So when we approach the limit when x approaches 2 from the left, and when we're approaching 2 from the right, what should we expect? So here what we're simply going to have is, so this is 2. When we're approaching it from the left, the graph is coming, it's coming. We have reached 2. So what is the y value of 2 at this point? When you look at it, it is 1. It is 1. Yeah. And then let us approach 2 from the right hand side. From the right hand side, we're coming like this. We're coming to 2. So it was coming down. So from the right hand side, when you look at it, it is also going hand in hand with 1. Yeah, oh yeah, okay, this is so nice. The left and the right, they are both 1. When we approach it from the left, it is at 1. When we approach it from the right, it is also at 1. Yeah, so but we're not yet done. So what about, so remember there are 3 functions, left, right, and also f of a. So meaning here, we simply mean f of 2. F of 2. So what is the value of the function when f is 2? So remember I said when we have a dot means it's not part of the solution. Yeah, the point is just there, but it's not part of the solution. Yeah, so like in this case, you can see that on 2 we have 2 points, we have 2 dots, we have this one and that one. So the one which is for f of 2, it is the one which is shaded. So f of 2, it is going with 2. So we have 3 different things, or we have different things, meaning the limit does not exist again. Yeah, so at least this one it tried, it was almost there. So the limit, you conclude, so you have to conclude the limit when x is approaching 2 does not exist, because it is dotted here, unless it is not shaded here. Yeah, so unless if it was shaded, then if here it was also 1, then it could have been true. Yeah, so let us do another one. Yeah, so by the end of the last example, you will have understood everything. So what about the point 3? What happens here at this point? So we're now going to 3, the limit as x approaches 3, 3. Yeah, so now here we're going to approach it from the left, we'll approach it from the right, and then we'll check f of 3, what is the dotted point. Yeah, so we can go through it. So from the left, 3 is here, and you can even draw a line to know where you are coming. Like you want to approach the line for 3. Yeah, so we'll start from the left. The graph is going, you can start from anywhere as long as you are going to, as long as you are coming from the left. So we've reached the point, it is 2 when we are coming from the left. What if we are coming from the right? It will go, yeah, it has reached. So when it is coming from the right, the point is also 2. And then what is the dotted line at 3? This is what it means, f of 3. What is the dotted line at 3? The dotted line at 3, or not dotted, the shaded. So if we had another point like this, we cannot consider this one because it is not shaded. So the shaded point at 3 has a y value of 2. So you can see we have 2, 2, 2, 2. So it means that the limit as x approaches 3 exists, and it is equal to 2, because from the left it is 2, from the right it is 2, and also the f of 3, it is 2 again. Yeah, so this one, it satisfies all the condition. Yeah, and then number 4, battery low. Okay, so number 4, we're going to say, let's quickly do it. So number 4, from the left, this is the left hand side, the left will always go like that. So from the left, it is at 1. So from the left hand side, it is at 1. What about from the right? There's no graph on the right of 4, so it does not exist on the right. And then f of 4, where is it dotted? It is dotted at 0.5. So you can see these values, they are not uniform, they have to be the same. So therefore this limit does not exist. Yeah, so now we're going to go to an exam question. Yeah, So like I said, even the one we're just from analyzing, it's actually exam material. Yeah, although maybe they can make some few changes. So this is how the exam will look. And then if you didn't understand well, you'll be like, that was so bad, an exam. Yeah, so unfortunately, this lesson will end here due to power issues. So in the next video, the video you'll find it on the link or on the comment. So just check on the comment of this video. You are going to find the continuation. So it will be very short.